pretty tough gig having to compete with that. But my name's Chris Giattina. I'm CEO of a company that designs, manufactures, and constructs healthcare. So we're fortunate enough to have some great clients. Brian is one at HCA, UHS, Encompass Health, Walmart Health. Thanks for the plug, Mike. They're all very different. They're leaders in their industry, whether it's for-profit acute care, whether it's behavioral health, whether it's rehabilitative health, or whether it's just simply the largest company in the world. But they're all united by a common desire to convert a project by project mindset to a product mindset. And they're doing that because they expect that they will reap the rewards of increased speed to market, of higher quality, and overall improvements in their enterprise value. So we're going to take a look at that. The pictures up here is it's a building. You just saw it in that video. It's a freestanding emergency department in Reno. It's one of a bunch that have been done. And it is a building delivered as a product, right? So it looks a whole lot like a building delivered as a project. What's the difference? Project and product. A product is delivered from a platform. It's pulled from a platform. And a platform is nothing more than this big box of things that make that happen. It can be hardware, it can be software, it can be standard parts, it can be materials, it can be supply chain, right? It's all of these things that are needed to normalize a platform so that you can make products. So let's unpack that a little bit. This is something you've probably all seen before. This is a diagram that I've shown here every year, and this is what we do. I'm a second-generation design architect. We start with ideas and designs, and we go to a building information model. It gets used way down here at the construction document, where the GC turns that into a series of bid packages, and it keeps moving, right? And way down here at the bottom, the owner gets to use it, right? And so that's what we're waiting for. And so in a product mindset, it doesn't look like this. This is what a project mindset looks like. And so let's take that. Here's a project. A project has an owner. And Brian takes a set of needs, and he converts those into a project. And if he's lucky, he has a program manager, a project manager that he already has on staff. If not, he hires one to do it. And then that person does a submittal process, and they hire an architect, an engineer, and a contractor. And hopefully those guys and girls are really smart. And if they are, they're doing all kinds of things right now. They're doing ad hoc work to create improvements and innovation. The contractor may be doing it, the engineer may be doing it. But at the same time, Brian has multiple projects. And so he's over here, he has a second project. And this person is occupied, so he has to get another person. And then they find a group of people, and if they're really smart, they're also doing things, right? And at the same time, you have it here, and here, and here. And what you get out of this is the groundhog effect. There is virtually no leverage or transferage of knowledge from the left hand to the right hand. It can't. It's happening simultaneously. Without that transfer of knowledge, you get unleveraged scale. When you get unleveraged scale, you're essentially a mom and pop hospital chain instead of a multi-billion-dollar-a-year deployment, right? So what we want to do is figure out how to do that. The other thing that just happens is this scales linearly. If one manager does 2 projects, then 2 need to do 4, 4 need to do 8, etc. Let's contrast that. This is a car. It's built on a platform. It's a product. That product might be a car. It might be a station wagon, a sedan, a pickup truck, an SUV. Could be any of those pieces. And it's pulling from this supply chain, from this embedded intellectual capital that took years and years, if not decades to make something at the top. And so what a platform does is helps a product leverage its design resources, something that are very scarce and expensive. It allows us to leverage sub-assemblies. It allows us to leverage supply chains. And generally, it helps us to make predictive product development and project delivery, right? So from a cost standpoint. So that's the difference. Now, if we take and see what that looks like, we take the same diagram except we change need with platform, because the platform exists a priori. It exists before the need is identified. It has to, right? It takes decades to make. So this platform exists. The designer pulls from the platform to create a building information model. And now it changes a lot. Now we go from a building information model directly to fabrication. The design, bid, build world moves away. We take it away. So that just simply evaporates. And so if you are involved in that, that probably just caused you a little bit of butterflies, or you think I'm absolutely nuts. Both are probably true. However, it doesn't change that this is a simpler, more efficient process for delivering complex healthcare. So, the architecture, engineering, construction world, the AEC industry, the thing that I grew up in, the thing that many of you grew up in, is a system, an ecosystem designed to go project by project. It's literally what it's built for. We knew that we couldn't change the hearts and minds of everybody by working through it that direction. So we changed it. We created an overlay, a filter that says design, manufacture, construct is our objective. It's going to say we're going to teach a legion of designers how to leverage manufacturing productivity, parentheses, we have to invent it as a group, right? So that we can simplify construction. Pretty simple. Teach designers to leverage manufacturing productivity to make construction simple. Underneath all of that is a technology called Weaver that undergirds design, manufacture, construct. It connects supply chains. It connects digital fabrication. It connects bills of material to designs, right? It's an important component. It's largely invisible to everybody, but it exists as ether that moves through the whole design, manufacture, construct ecosystem. If we were to visualize what that looks like, we say we take raw material, which is coil and log and tube and plate and sheet, and we use digital fabrication processes to turn those raw materials into bespoke parts. We take the bespoke parts and we turn those into subassemblies with operators, not tradesmen. The operators then can turn those into two-dimensional panels. Those panels can then be assembled into boxes that are volumetric and non-structural, which can be nested in Uber modules, which are structural modules which can be stacked vertically and horizontally, which aggregate to create buildings. We don't have to go linear. We don't have to go a straight line from 1 to 7. We can take raw material and go to subassembly. We can take parts and go directly to the field. We can take any one of these pathways that we need in order to optimize the exigencies at that site. So, standard modules at the beginning. We talked about this here 3 or 4 years ago, maybe 5, I don't know. Standard modules are the ante of the platform. You can't make real progress until you understand what a standard module is. I'm going to unpack that. So this is a BLOX wall. It looks like any other wall. It's got a surface on it. This has a Herman Miller casework that's attached to it. And if you look beneath it, there is a structure that's underneath that, right? And so if we pull those panels off, what we see is a bunch of intelligence behind that. We have a wall that's made out of a CNC coil that turns it into a specific frame. We have parts that are modular cassettes for mechanical, electrical, plumbing that go together. Those pieces work with a series of gaskets, brackets, sound isolation pieces, and others to create an overall system. That overall system is what we use to make standard modules. These standard modules are brine standard modules. We've been using them with HCA for the better part of 7 years. They look similar but are different than UHS's standard models, which are different but similar to Encompass's modules. So all of these pieces are made out of the same BLOX wall platform. You can make them out of you can make them in any shape or color, though there are some that are more efficient to make than others. So that's an important component. So from that, then if standard modules are the ante, then digital configurators create mass customization, which is the ACE card. Okay, so the ACE card says that we can take all of these normalized pieces and begin to make bespoke shapes and sizes using digital tools to create outputs which are manufacturable, which is a big deal. So that's kind of the platform in its physical, and in its digital world, it relates by taking sensors and building those into the panels, which can collect data, which can be reported out. Really, really basic. The idea there is that we extend the useful life of the building. We're no longer thinking about the optimization from need to delivery of building, but rather from need to delivery of building to the life cycle of the asset. So the objective of the platform is not to make parts, it's to make buildings. So putting them all together is the thing that we're focused on. We look to the aviation industry for guidance here. Boeing makes a Dreamliner. It's a heck of an airplane, 787. It is faster, lighter, uses less fuel, and it's comfortable, great ride. After they got through all of their startup problems, they're making this in chunks. It comes in 22 chunks that are made in 9 countries. A chunk is a big thing, right? And it's got all of the stuff in it, not just structure or paint or hydraulics, but all of the things that are connected. And it's coming to a plant in Charleston, which is what our job sites are trying to look like. And all of those parts come together to make a really complicated airplane really fast, right? And so our chunk is an Uber, and an Uber is 15 feet wide, 15 feet tall, 60 feet long. It's chock full of complexity, which manages to work in an overall building which looks like this, right? So here's a freestanding ED. It's made up of a nominally 15 large modules. Each module looks like this, right? So you can see that there are a number of those in here. If you isolate that, it looks like this, which is a level 500 building information model. It's pretty robust. It collects a lot of data, and it gives a lot of data or communicates a lot of information to the builders of it. This is our manufacturing line in Birmingham, and we make 5 of these big modules a day, every day, which is been a work in progress. So this is a job site in Reno. In Reno, the site's prepared. You can see the trucks lining up kind of like a caravan in the back. So 9 o'clock in the morning, 8 o'clock in the morning when they started, they got the crane mobilized. First one's in by lunch. You're looking at half a dozen in. This is the view looking up from the nurse station, which is that center core. You see the rooftop Uber flying in. You can see it's mechanical, electrical, plumbing. This is by about 3 o'clock in the afternoon. I'm looking up from that space, and I'm seeing an enormous amount of complexity that was a gravel bed when I got there in the morning. This is a man connecting, stitching pieces to pieces, right, which is happening almost immediately when it goes in. This is a view from above. This is the view at the end of day 2 where there's an RTU installed and energized and the building is dried in and conditioned. 2 days. The inside of it looks like this after another 150 days, which is a building ready for occupancy. It is what you would expect to see in an FED, which is triage and exam rooms. X-ray, CT, the big nurse station finished, the outside. So we started this FED program in 2017, 2018. We've delivered 20-something pieces, or 20-something buildings in about 6 or 7 states. We continue to evolve this, but it's not good enough. We know it wasn't good enough. It was the beginning. And so our clients want us to be faster, and they want to have more variation. So how do we begin to think through that? We said we've got to remove some of the complexity that you saw in the ceiling. And so we started with the plan again. We stripped it down to its base so we could just understand the structure. We looked at the electrical, then we looked at the mechanical, and then we looked at the plumbing. And you can see in all of these pieces, there is a lot of connections. A centralized version has over 1,500 connections, more than 100 per Uber module, right? And so what we wanted to do is erase that and say, how do we simplify that? And we came back with a significantly simpler layout, which was requiring more work in the plant, but to get less work in the field. And so it was a decentralized system that took it from 1,500 to 75 connections, which is a 95% improvement. So this is the prerequisite to going fast. It took us really 4 years to develop that. So in walked a client that was really weird. We focused just on healthcare. At least that's what we said. And we had a retailer come in. They said, we want to get you to make clinics for us. And we said, that's not exactly what we do. We're an acute care provider. We aren't focused on. They said, we want to make healthcare that is accessible and affordable at scale. And I went, so wait, say that again. And when they said that, when they said their mission was to create accessible, affordable healthcare at scale, I mean, our team lined up, right? That we could get behind that. That's a mission that we care about. So we took that and we applied the lessons that we just learned from the freestanding ED after 3 or 4 years. We modeled it. It broke into, this is nominally a 7,500 square foot primary care clinic. It's got 10 exam rooms, which includes dental operatories, primary care, vision. It has a lab. It has radiography. It has all of the basic things that you would think about. And we broke it down into these red pieces, which were the Uber modules. And this is what it looks like. So, the metrics. We've done, that was in Noonan, Georgia last November, so less than a year ago. So since then, we've done 20 some odd projects. We have more that we're working on. We started at around 150 days in terms of speed. We got down to sub 60 days. Then we changed AHJs, went from a Georgia to a Florida, ended up losing a little bit of time, and then we've worked our way back down to sub 60. Our goal is to get to 40 days. Speed is an important component. Keep in mind that, that this is right now, during a pandemic, with all of the attendant supply chain issues, we're delivering one clinic every 2.5 weeks, on a track to deliver one clinic every 2.5 days, right? So that's really, really fast. The second part is cost. And so during this time, we've seen the expectation that it costs more to develop a platform or to develop a program within a platform. It takes time and reps to work those out in the projects, but then you can see that there's a break-even point, and then there's a net overall gain. It's possible to move at this speed with this level of efficiency when you have a product mindset, right? So that's all that it takes is a product mindset that tries to leverage a platform, and your team, internal team and external, share that same common thread. And so as a teaser for next year, the Uber patient room, which is a universal patient room where we can take and pack in a med surg or an ICU or behavioral health or a rehab patient room into a box and deliver that as a product, is what we're working on. We are fortunate enough to be doing this one right now with a colleague who manages a large healthcare system. We have over a dozen of these projects, de novo and bed additions, underway right now. They're pretty handsome buildings, and what we'll look forward to seeing is the results of that next year. Thank you all for your time and attention, and the bar's open.